Thanks, Dan. So first of all, as Dan mentioned, my name is Jim Sweeney. I'm a senior product manager at PerkinElmer, responsible for many of our service solutions, particularly in the area of IoT. So first and foremost, I hope everyone is safe and doing well. So I'd say that for myself, with the current situation, the rate of information and change we're seeing in the past few weeks has been unprecedented. And I'd say that even before these events, it felt for me things like this, and particularly technology, were constantly changing. And that change was accelerating. And I think the pace we're seeing now is becoming the new normal. An area of particular interest for me that has experienced this acceleration is the Internet of Things, or IoT. The number of devices that can be connected and how they can be connected continues to grow. This connectivity is touching many essential parts of our lives today and making a positive impact. And I'd say, what about that same question, not only in our personal lives, but in the lab? How many devices or instruments are already connected or have the ability to be connected in the lab? So a little later on, I'll get into specific examples. But if you think about the instruments that have connectivity or are using connected sensors for the environment example, or for monitoring critical parameters within an instrument or asset like temperature, think of refrigerators or freezers. And this isn't something that's new, as many of these instruments have been connected for years. Really, I think the difference today is that the technology used and the business value that you can get by connecting or using the IoT in the lab has never been more compelling. So we want to take a look across a couple of opportunities in the lab. And I think first, let's take a look at an example around research reproducibility. We know there's all kinds of research about the challenges around research reproducibility. So how can we use IoT sensors today to potentially impact that challenge? And then let's look at the instruments themselves. You know, as these instruments become connected or the environments that they operate in are better well monitored, how can we change the performance of those instruments, make it more predictable? And then last but not least, around asset and research productivity. How can we, again, connect to an instrument to improve not only the research reproducibility, but asset performance, such as uptime, as an example. Across all these areas at PerkinElmer, we've been documenting different customer use cases from our various conversations. So if you look across here, monitoring analytics, I've listed quite a number of different use cases that we've seen across our business. In this presentation, I'm going to focus on the three highlighted in red, again, focusing on research reproducibility around monitoring light levels, instrument performance around an HPLC example, and then finally, utilization of lab assets for utilization and capital equipment planning. So let's move on to the first use case. When we're looking at vivariums, light cycles are extremely important to measure and report on any anomalies. It is very common to have specific light-dark cycles, such as 12-hour light, 12-hour dark. Interruption of these light cycles will cause stress and actually decrease the breeding performance of mice. Having the ability to get notifications through email or text is essential to troubleshoot or resolve any light cycle issues. In this example, the lab noticed that the mice reported births were not in line with the original projections. The light cycles were being controlled by, but not being monitored at a granular enough level. Connected sensors were deployed to monitor the environmental conditions in the lab, and they measured the light levels every 15 seconds. As the data started to be collected and analyzed, it was determined that the light cycles were being interrupted by ongoing construction work in the lab during non-working hours. So moving on to my next example around HPLC variability. Instrument capital expense and ongoing maintenance are two of the highest expense categories in the lab. Given the complexity and expense of these, instrument manufacturers will include recommended operating conditions for optimal performance. Ensuring instrument uptime and optimal operation is a key driver of lab productivity. HPLCs have a typical recommended operating condition of 15 to 30 C, with the guideline of also not having rapid temperature changes in the lab. These rapid temperature changes can cause erratic results. This example was actually documented online in an article at The Scientist. You can see the link to the right. The use case was the scientist was seeing series of peaks that indicated the components of a drug were jumping around all over the place. The supplier for the instrument was not able to determine the root cause of those erratic results. Again, a connected sensor to monitor the environmental conditions was placed directly next to the instrument. With the granular measurement of the environment, it was quickly identified that the HVAC system was blowing air at specific times during the day. Once this was understood and resolved, the results returned back to expected values. The last example is also for asset productivity. In this example, a lab had over 200 liquid chromatography systems that were being maintained. There was an assumption from the lab manager that some of these LCs were not being used. The challenge was that there was no data on the utilization, only anecdotal feedback from the scientist. Of course, the scientist said that all the LCs were being used and were needed. The lab manager initiated a plan to replace or upgrade some of these LCs. Those 200 LCs were connected to the Internet of Things and to capture utilization data. This data was collected, analyzed, and overlaid with service data. This analysis can be seen in the upper right side of the chart. With the combination of utilization and service data in a visualization, several systems were able to be identified that required further investigation. Again, the system identified candidate systems that we had to go back and talk to the scientist about the specific context of their use. The results were that 2 systems were identified that could be decommissioned. These systems were older systems with a high number of repairs and low utilization hours over the past year. Once presented with the data, the owners of these systems agreed to the decommissioning. One system was also identified that was relatively new with no repairs and 0 utilization over the past year. This system was able to be redeployed with the permission of the owner to another lab that had requested a new LC system. So this lab saved the purchase of a new LC system by repositioning one that was underutilized and relatively young. By taking advantage of the new connected technologies for the labs, organizations will see improvements across research reproducibility, instrument performance, and asset and research productivity. Automation and continuous granular data capture across these areas will result in decreased cost and increase in the return on investment of these areas. If you'd like to learn more about these, as well as some of the other use cases presented on that slide, I'd recommend that you go to the PerkinElmer.com website, and you can actually download the white paper that goes into detail on these use cases as well as the others. And if you're interested in more discussions with myself about the solutions or my experiences with connecting assets in the lab using IoT, feel free to reach out to me directly through my email here. Again, thanks for your time today, and with that, I'll return it back to you, Dave.
Thank you very much, Jim. Everybody, I wanted to thank all of our speakers, but Jim, we had one question here before I continue on to my next statement here. 1 second. So with the IT solution, how do you deal with security?
So there's always a question that comes up, and I think there's multiple levels that you have to understand with security. There's not only the application security, but also the connectivity and how you're transporting that. So typically what I recommend is that very early on, we need to involve your IT partners with us. And typically these type of solutions, or even any type of connectivity, will go through an IT security review. So I think the key there is you have to become partners with your IT group and work through that security process.
Okay, great. Frank, if you don't mind flipping your video on, I just wanted to open it up to everybody else, all of our attendees. If anybody has any additional questions, please let me know. Also, while we're waiting for that to occur, I'm going to launch a poll that we would like to just get a little feedback from you on, if you could, before we come to a close here. And this is just, we're trying to get a gauge on the material that we're doing here and how people felt about the time frame. So please feel free to vote. One additional question came in, which is for Jim. What options are available from a connectivity standpoint that PerkinElmer normally uses or recommends?
So as far as connectivity options, if I understand the question, I'd say there's connectivity to all different types of assets. So we can connect directly to the instruments, kind of what Spin talked about, using different types of connectors. But for other areas in the lab that may not have a PC connected, we can deploy what I'd call secondary sensors to either sense the environments or to sense the asset conditions through either understanding its usage or its temperature, for example.
Excellent. All right, thank you very much. I would like to thank all of our panelists, both Frank, Jim, and certainly Spin. We'll be getting, actually let me turn my video on so you can see my ugly mug. I'm still talking here. We'll be getting a new LRIG pen that will become available for people probably at our next meeting. We're currently, based on this particular meeting, as you may have seen, we did cancel our LRG New England exhibition. We are hoping to have another event around that time frame, so stay tuned for that. And again, we're always open to input, so if you have questions or comments, you can reach out to myself or any of the members of the LRG community. Also, please remember that if you're interested to pass on the information regarding our teacher grant, our educational grant, as well as our sponsorships that you may have seen through the website. Please feel free to pass that along to people that may be interested. We are trying our best to support the local STEM initiatives in the New England area. So with that being said, I'm going to close this meeting. Frank, Jim, thank you very much. I appreciate your time. To all of our attendees, thank you very much for taking the time over your lunch break, and hopefully we'll see you at a future event. Thank you very much, everyone.
Thank you.